Welcome to the Plant a Trillion Trees podcast. I'm Eva Monheim.
And I'm Hal Rosner. We are both certified arborists through the International Society of Arboriculture. The purpose of our podcast is to encourage tree planting and proper tree care for our urban forests, which include neighborhoods, parks, and other open spaces.
We will also cover a myriad of tree topics, including the important role trees play in relationship to the climate crisis. Thank you for joining us. The Plant a Trillion Trees podcast is happy to announce that we have won 2 Garden Communicator International Silver Laurel Medal Awards for Best Podcast and Best Podcast Episode. We've also won a Garden Communicators International Gold Laurel Medal Award for a Best Podcast Episode. We'd like to thank Garden Communicators for their recognition.
Verdant Earth Educators provides dynamic in-person training and online learning opportunities for environmental and horticultural businesses. Owned by ISA certified arborists and former university faculty, the Verdant Earth Educator team provides consultations on tree care and recommends climate-resilient opportunities for your valued green spaces. Verdant Earth Educators is all about seeding knowledge for success. Find Verdant Earth Educators at verdanteartheducators.com.
Monheim Microphones designs and handcrafts top-tier studio microphones and preamps right here in the United States in Hollywood, California. Their incredible line of innovative microphones and designs are used around the world by everyone from podcasters to top-charting record producers and singers. Monheim Microphones, unparalleled excellence. MonheimMicrophones.com. This podcast is being recorded on October 11th, 2024. Dr. Anna Paltseva is a distinguished urban soil scientist and educator, currently serving as a professor in the Department of Agronomy at Purdue University. She earned her Ph.D. in Earth and Environmental Sciences from the CUNY Graduate Center. Dr. Paltseva's research focuses on urban soil contamination, particularly heavy metal pollution, and its impact on urban agriculture, ecosystem health, and public well-being. Utilizing advanced technologies such as portable X-ray Fluorescence, she works on innovative soil remediation strategies in urban environments. Beyond her academic work, Dr. Paltseva is a prolific speaker, author of multiple peer-reviewed papers, and the founder of House of Soil, an initiative that connects soil science and regenerative fashion. She is also deeply involved in outreach and community engagement, promoting environmental education and sustainable land practices. As the author of Urban Soil Guide, Dr. Paltseva provides practical advice for soil testing and management in urban settings. Welcome to the Plant a Trillion Trees podcast, Anna. We're delighted that you could be with us today.
Thank you so much for having me in the show. I'm really excited sharing my knowledge about urban soils and reaching more audience.
It's a very, very exciting topic. Soil is the backbone for everything, right?
Absolutely.
It's like the good stock in a soup.
Yes, I definitely agree with that.
So what I want to start with, I love the story that you told about how you were influenced by your childhood and your parents in your home garden in Russia. I just thought it was so fascinating. And can you tell us from that point, like how did you become a soil scientist? What really perked your interest in soil?
Yeah, that's a great question. I definitely did not plan to become a soil scientist. I had different ideas for my career when I was a teenage girl. But as I was growing up, it was part of our culture to grow our own vegetables, our own food. Part of culture, everyone is doing it, especially in rural areas. In the 90s, we really didn't have that many stores and you couldn't buy vegetables in winter, or they would be super expensive coming from abroad. So really need to learn how to grow lots of vegetables during the summer to preserve them for winter months. And we have big cellars in the houses or under houses, which are colder temperatures, and you can keep jars with pickled vegetables jams, fruit punches with boiled berries and fruits, and of course, lots and lots of potatoes and carrots or onions, something that can just stay fresh for a long time. So my parents are professional agronomists, so they studied agronomy in school. They know how to grow crops in big fields. My father was a manager at a collective farm for a quarter of a century, and he still farms for the family. My mom, we both met in college, so agronomy was part of us way before. And everyone in my family for generations been doing farming or gardening. So this trade, really family trade, that led me to my profession, which I didn't realize until a few years ago when I started thinking back what happened. And honestly, I like the nature. I like the ecology. I like to connect things, connecting different processes and components, what we see in ecosystem. And in high school, I started to study ecology, although it was not part of the subject in the school, but I really liked it. And I started going to some competitions, and I even won state competition and was awarded with a free tuition to the best university in our state. So I went there for ecology, and I still continued the path. We studied some soil, which was fine, but I really was interested more in applied ecology and more testing. I did research on water quality and sediment, but it really changed when I came to Brooklyn College. I moved to New York City. I transferred to college there. And it's when I was like, let me see. If I can get water extractions, I can do water extractions from soil, and I can carry out my research. And here I am. Now I run my own labs, and I have my own students who do soil testing with me, and I carry out the legacy of agronomy and agriculture, but studying environmental pollution, so we can actually mitigate some issues that we added artificially to our soil during the process of mismanaging our soil. So I want to bring back flavors of fruits and vegetables that I grew up with, growing that produce in a very clean soil.
And so your book is The Urban Soil Guide.
Mm-hmm.
And just for clarification, is it an ebook or it will also be in print?
I am showing you right now the hard copy. I have it. It's 150 pages or so, published by Springer. It's on demand, so you can order as many copies as you want. But there's also ebook version if you want just to have it on your Kindle or the PDF. So really easy, wherever you can use. I prefer hard copies because I'm an old school. I like to take notes. Yeah, it's urban soil because I like pollution. Despite growing up in the rural, clean environment, I want to fix it. And I'm fascinated by cities. You can see Indianapolis behind me, quite urbanized area, lots of formal industries. And urban soils are fascinating. And I think we understudy them and undervalue.
Yes. Well, just for an update, I got my copy, and I'm excited to talk to you about a serious update because I'm looking at Henry Foth's Fundamentals of Soil Science, which is what I used in college, and it was printed in 1947. So your book is timely. I have a feeling Mr. Foth probably didn't even have to talk about pollution, but here we are 60, 70 years later, and it's certainly much more of a serious topic.
It was really easy to compare.
Yes, absolutely. So it sounds like growing up in Russia, I can just visualize a beautiful family garden with a lot of produce coming out of it. And I have to say, I'm going to have to really resist asking my own questions because after arboriculture, I have to say, I think my passion, it really is vegetable garden. And I'm always happiest when the parsley and the kale and the collards are really growing well. But you're pretty concerned then, is it safe to say, about soil contaminants in our big cities?
Yes and no, depending on what was done to the soil before. So I think it's important to investigate, and for new homeowners or for parents, know what's in their backyards. The research shows that backyards may have higher concentrations of metals compared to public areas, because public areas are more maintained. Agencies, non-profit organizations, private company who own the land, they do something to the landscape. They'll grow lawn, they add compost, mulch, but backyards very often stay untouched, and if something was deposited there decades ago, it still would be there. So it's really important to know what was in proximity, even like a mile away from the home, is if you want to grow something, or if you have children playing in the garden. And what we see is that the inner cities, historical sites, historical centers, or industrial areas, of course, would have higher concentrations of metals. And typically it disperses closer to suburbs, to newer suburban areas. So if you're in a historical area, so like city center where the city began, and there used to be some factories, maybe smelters in New York City, we talked earlier, there are lots of Navy yards. You really need to pay attention to what's in the soil.
I know here in Philadelphia where they had the old factories and then the ground sits vacant for a long time and then people forget what was there. Mm-hmm. And that's where you really run into trouble, especially if you start to put housing developments on these old properties where you had industrial contaminants. You know, that's where the red flag goes up for me.
Absolutely. And something you can do to a certain degree, you can look back with Google Earth, what was done before. Each city has its own images, like, you know, as far as it goes. But another thing is really great is sandborne maps. And this is something we use in research. You can just get us through a public library, like it's open access to people. So sandborne maps, they used to be used for insurance purposes, but they actually have very good record in old days of the city landscape, but what was there before. So you can go back in decades or maybe over 100 years ago in the 19th century, maybe earlier, and see what was the new property. And it's really interesting to see how it's changed.
Sandborn or Sandborg?
Sandborn.
Sandborn. And this is the first time I'm hearing about these. This is really fascinating because we studied soil at school and nobody's ever mentioned those kind of maps.
This is something we've been using like in the research, and before they were not digitized. Maybe
that could be why.
I used to use them a lot, like for New York City. Some of them, it's like Atlas, they scan pages, and you can like yourself rotate the page and like look where things are. But some of them can be even digitized and you do like search through them. But yeah, maybe you just didn't have access to them, or you had to go to the library to flip through them. But now it's electronic and it makes it more convenient. Yeah, you can look through old records for probably most of the cities.
Well, I like the fact that like Harvard and a lot of the big universities were scanning so many documents. And I'm sure, these kind of documents got scanned in those kind of programs where it makes it accessible to people who are doing research, because we really didn't think about our cities back 100 years ago for having pollutants, but they were there. I mean, yes, old tanneries, butchers, in the city of Philadelphia. I mean, we had so many different things, and from an industrial standpoint, tannery was a real big thing, and you had a lot of pollution from tanneries.
Well, we like to heat our homes with coal too.
Oh, absolutely. Absolutely. My grandmother still had her coal stove when I was a little girl.
Yeah.
They were like some of the last people to get rid of their coal burning heater, rather, because they had a wood burning stove in the kitchen and half gas, half wood burning. And she still had that when we were kids. She was still using it. And that was in the 60s.
My grandparents had it in the 90s because they didn't get gas pipes until early 2000s. Yeah.
Oh, my. Yeah.
So the things that we don't realize.
Well, Anna, I wonder if you could just walk us through, for lack of a better word, the mechanics of how arsenic and lead find their way into the vegetables. Hypothetically, if we talk about leafy greens, lettuce, kale, collards, are we concerned about the particulate on the surface of the leaf, or are we thinking about it at a molecular level, that toxins are being pulled up into the plant through growth?
You're asking a very knowledgeable question. It both, and different plants have different responses, so different behavior. We did some analysis in New York, and our colleagues before us did it. A lot of research came out from Cornell University on this. So basically, root vegetables can have uptake through their roots, but also through the skin. So particles attached to the skin, so like radishes. It's not through uptake, it's mostly through adhesion on the surface of a radish. And you don't typically peel it, so you eat it together. If you peeled it, you reduce it, of course. With carrots, it's different. It's actually uptake and surface contamination. You peel a carrot, it's good, but it's the core inside of the carrot has, it's like a sucking mechanism. So you really cannot peel the core inside of the carrot.
Right.
So really, you need to be mindful to grow carrots in a soil that might have some contamination. The other vegetables you can peel, and it reduces contamination. Carrots a little bit trickier in this regard. But then when it comes to herbs and leafy greens, it's actually mostly contamination from surrounding areas, from splashes, from dust, not much of uptake. And we know it because we analyzed samples from gardens in New York is comparing aluminum concentration in our plant tissues. We grew multiple vegetables, multiple herbs, leafy greens, and what we found that aluminum was present in soil. But if you know anything about plant nutrition, like what they need, plant nutrients, what they need for growth, aluminum was not on the list.
Right.
So aluminum doesn't need to be in the plant. If it's there, it means it's a surface contamination and it got on the sample. And we tripled wash our vegetables. So like it's such a strong adhesion to the surface, so we cannot wash it off. It means that we can still consume it even though we washed our vegetables. Washing is extremely important. It reduces contamination, but we can't completely get rid of. So this is something to keep in mind, and especially when it comes to leafy greens and herbs, they have very large surface area, so they can capture more. And they have surface that is uneven, like hairy, if it's like parsley, or some other plants that have a little hair, so it captures more particles. But the good news that fruit vegetables, if we talk about like peppers or tomatoes, eggplants, something you grow, squash, something grow further from the soil that doesn't get splashes from surrounding areas. And they have tomatoes or like eggplants, they're very flat. So you can easily wash it off. It doesn't adhere as much. So plants that grow further from the soil are safer to grow in moderately contaminated soil. Also, these fruit vegetables, they have physiological barriers inside of them. So they naturally prevent themselves from taking toxins in, while root vegetables, they have very weak barriers. So the toxin can go inside of a plant. So this is really interesting, the different behavior and response of a plant type on uptake of metals. Our research showed that radishes would prefer to take up radishes, while carrots would take more lead. So there are even differences like this.
The phytoremediation of certain plants, that's why they use beets for phytoremediation, or that's why they use sunflowers for phytoremediation in soils. Is that because they know that's what they're really good at, pulling up?
So this is the good question, good insight, because phytoremediation for lead is actually a myth.
Oh, that's interesting.
Yes, there is no scientific proof to find a plant that can take up enough lead from soil that would clean it up. It would take hundreds of years to clean up against lead in particular, because it's not mobile metal. It's enough to contaminate vegetable to make it unhealthy for human consumption, but it does not accumulate enough metals in its tissue to clean up soil at the rates that we would need. So we cannot grow a bunch of carrots to clean up our backyard. And all my colleagues from Brooklyn College actually wrote a paper, a critical review on multiple plants that we found in research that could be potentially used as hyperaccumulator plants for phytoremediation. But there are like 3 criteria that they needed to meet, and none of the plants could meet all 3 criteria to actually effectively phytoremediate the yard, let's say. But it could be phytostabilized, and some plants could take lead in the tissue and would stay there for longer time. So phytostabilization is more promising than phytoextraction in this case.
Gotcha. And I would imagine that that's also why in large areas where you want to stabilize your soil that may have a lot of contaminants, diversity is really important, especially from an ecological standpoint. The more plants you have, the more work they all do together rather than separately.
Absolutely. And different metals have different responses. Like arsenic is more mobile. Arsenic can be phytoremediated. And there are some successful cases with that, like nickel or copper. There are other metals that are more easy to remediate compared to lead. It's very particular for lead because it's so stable in the environment. But to your point, to grow different plants, absolutely. It's one of the recommendations to remediate soil is to grow plants, have covered soil, and it can be, flower bush or lawn, something, some kind of greenery. So there's no resuspension of soil particles into the air. Plus, what is really important, the addition of organic matter. It can be naturally by like these plants are dying and they're falling back and they decompose in soil, or you can add organic matter in form of a compost, mulch, biosolids, biochar to remediate soil. And it's really beneficial for plant growth as well as for binding lead into organomineral complexes and making it less toxic, less bioavailable, so less available for uptake by plants or organisms. So this is one of the best recommendations we give, is to add organic matter into soil to remediate against pollution.
I'd love to go a little deeper on the remediation. And I'm also thinking, again, Eva mentioned the community garden programs here in Philadelphia, which have been around since the early 70s. Remediation, it's still a recommendation to add generous amounts of organic matter, and they will bind lead. Is that what you said?
Yes. There are other remediation techniques, of course, like phosphorus, phosphate amendments would work as well. The issue that we might counter is that you need to do some math to know how much to add and in what form to add phosphorus. So it actually has a chemical reaction with lead, and that requires some lab testing. So unless it's supervised by a scientist, I think for a regular gardener, it would be very challenging to figure it out. So for a gardener, it would be the easiest option is to add the compost or mulch or biosolids, biochar, and dilute the concentration. But also it forms the organomineral complexes that hold on to metals. The thing is, nothing is permanent, and you need to monitor the levels. So in several years, when this organic matter will break down, you need to remeasure again and see what's in the soil. So there's no like a perfect solution that you once remediate and it's gone. It goes somewhere, right? So we kind of redistribute it in a way.
When I go to different people's homes, I always say, you should be testing your soil at least once a year. That's my recommendation. But some people say, no, you don't really need to do that. But I find that you're saying the same thing. It's changing over time. So if you're the head of the ball rather than behind the ball, I think it's much easier for you to keep that soil maintained healthy. Is that true?
Yeah, and you're right. You should be testing at least once a year, like before growing season. It's just you have to choose what to test for. Something like pH, nutrient test, or salinity, maybe organic matter content, something that's more dynamic property that changes over season. You need to test more frequent. So at least once a year, like before you grow something, you want to test to see what's in it, so you amend it. But something like texture of the soil, it doesn't change unless you bring a bunch of standard clay to your yard. Texture doesn't change, or pollutants don't change unless you do something to it. So you really can test only once for this, and next time you will do it in several years. So you don't have to test for absolutely every single soil parameter every year, but for some chemical properties, you should test it every year to make it more like informative decision. If you need to add fertilizers or amendments to the soil, how would you know?
You were talking about arsenic, and I think I was telling you the story about my cousin who bought a home in South Jersey, and it used to be all peach orchards.
Yeah.
And they sprayed a lot of arsenic on those peaches. And the groundwater and the well water is so contaminated that they couldn't use it. So they have to pay to have their water brought in by truck. And you think about that, and there's not only her, but the whole development that she's in has to have their water trucked in because of arsenic poisoning in the wells. And so I don't think there's much that they can do about that, is there?
Well, that's probably, I know some of my colleagues did the research in Bangladesh because people have serious problems with like geological. That's a good question. I wouldn't know the specific answer to this, but maybe there are some filters that could use for water when it comes to the house. But yeah, I don't know. That's good to do some research. But
I think it's important important that people like yourself and other people that are in soil science are looking at these things and constantly coming up with new ways to purify our water, because there's a lot of issues, around water, especially with the PFAS and everything else that's been going into our well water and our drinking water, our city water.
I want to get back to your book a little bit, Anna, because if I understand it correctly, and it's an excellent presentation that you've offered the reader, there is a series of tests, right?
Yep.
And quick follow-up question, who is your book targeted for? Because my first read through is, it seems like you could even start like in 8th grade or high school and start working with this book. It seems like it's geared towards both the student in the lower grades, but also the professionals in the field in horticulture and such.
Well, I'm glad you noticed it, because indeed this is something I was trying to make it eligible for both groups as an introduction to soil scientists, to soil science for future scientists maybe, but also for green professionals. Somebody can take it with them to the field and not to spend too much time overthinking and not to have like official degree in soil science, to really make soil science more accessible and understanding, more simplified. There are a lot of resources out there on soil science, especially for like farming, for big ag, but there is nothing really for urban soil specifically. And this is why I created the source. One is for me to teach. So 2015, I started teaching at botanical gardens in New York City and New York Botanical Garden and Brooklyn Botanical Garden. And I was like, I have no idea where to take these materials. And I would spend so much time like Googling, looking at different labs, something that I can teach adults, because that's where adult education courses, continuing education. And people would come after work, they had full-time jobs and they wanted to learn horticulture, landscape design, and soil science or soil management courses were part of their curriculum. I was like, I need to make it entertaining for 3-hour class in the evening. And I started compiling different labs, different tests we can do in the classroom. But those were for people who were changing their careers. Some of them were hobbies, but a lot of them were changing their career. So I wanted to make something useful, something like college level, because at the same time, I was a PhD student. I was teaching at Brooklyn College. So I had access to labs and access to students. So I tried to bring this accessible college level education to make it fun for adults who forgot about science, and I wanted to get them excited again. But also I had to teach undergraduates in soil science that never had soil science before. So that's why I think this could be used for sure for professionals, green leadership professionals, for introductory science students. They could be for high school students for sure, or even younger, as long as they're supervised, because there may be some labs they need to know what they're doing so they don't mix things, something. But yeah, the idea is to create a resource where people can get excited to test something and learn more, and also saves money, because if you know how to use a kit of like NPK, nitrogen, potassium, phosphorus, or pH and salt probe, you buy it online and you can have it at home and retest it instead of sending it to the lab and wait results for a few weeks.
Could we ask you to walk us through one of the tests that's in the book?
You want me to tell you what it looks like?
Yeah, like salinity might be an interesting one, or just to give our listeners a taste of what possibilities
and
are.
I do want to point this out that we've been talking a lot about vegetables, but trees are also included in that, especially fruit trees and nut trees and things like that. So I just want our listeners to know that we haven't forgotten the tree bit.
No, actually, it's a great point. My book recently was used in Quebec, in Canada, in workshops for arborists. I had a gentleman email me about the book, and I connected with my editor to get some copies for his.
Oh, fantastic.
And then, yes, he posted on LinkedIn and sent me a good feedback that people bought the books, who attended the workshop, but they were professional arborists and they wanted to know about soil. And definitely, it's even if you don't grow any plants, but you want to play with your kids in the yard, you want to, have some basic understanding of science and teach them something. It's a great activity. And a lot of people can just use the book and to create workshops, like science workshops, but also like kids activities.
That's what I was going for, like camps. summer camps where kids can learn
Yes.
where they're playing so that they can actually see and learn about what is in the soil because it's so much fun. I don't think people realize how much fun it is.
Oh, absolutely. Gets your hands dirty and look at the microscope. You see things that you've never seen otherwise. It's really fantastic. And I studied more like water quality, my undergrad, right? But I was able to apply this knowledge to soil science. So what we study in science is it's a scientific method. And even if you use this method, you'll know how to apply them in another science.
Exactly.
Like you can have an idea how to test air or water or like, I don't know, sediments. So those like basic knowledge that we can just use to get interested also in STEM in general.
Yeah.
So here is the book.
Yeah.
Do you want me to go over the salinity quickly?
Surely, that'd be fantastic because street trees certainly struggle with salt. Yeah.
So the book, each test, each lab, as I call it, lab activity has a little abstract, and then it goes to the goal of the activity. And this one is to determine soil salinity levels in urban environments using electrical conductivity and total dissolved solids. I give 3 paragraphs of theoretical background just to understand what electrical conductivity means, how it's connected to total dissolved solids, how we measure it. Provide always a bunch of images, something in the natural environment, and also how to do the lab procedure. Has the photos of the instrument or a kit that was used. The lab exercise has a duration. It's a proximity, like 40 minutes. People have an idea. Rating is easy. And then setting outside, classroom, home, or lab. And then I have materials. Material list that people would need. A salinity meter, which you can buy online. Deionized water, you can buy in any store. Standard buffer solution that comes with the salinity meter typically. And maybe beakers or tubes. During COVID, I had to teach soil classes online to my students, and some of them were advanced soil science classes. So we got creative and we used even kitchen supplies. On the kitchen, this is where we did our soil test. My laptop was literally on top of a sink, and we all had to show each other the results on the laptops. It was hilarious, but we managed it.
But the idea is it goes to prove that you can do this no matter what your circumstance.
Yes, and actually one of the images was another lab. I had a photo of like lab setup with like, beakers and cylinders, and then just the plastic cups with the coffee filters, which we also work. So I describe it in a detailed procedure, how to do the procedure, the test, and all these labs were tested by my multiple students all over the country almost. I've used it for many classes and always received feedback back from my students, so I get improve it. And the book was also used a couple of other college courses, other colleges now. So I got the feedback to make it as clear as it can be. And once the students do the procedure, then I have interpretation and results. So sections. So in a table form, they should write down their results is like what sample they used and what measurements they got, and then what the results mean. And I typically have either it's in a word form or in table form, what numbers mean, and then interpretation, what they can do with this data, how it can be harmful, at what ranges of the units they receive, wherever the test is. And we can say, like, is it low? Is it high? Is it okay? And what you can do briefly to improve it. And then I have other questions here at the end, because if we use it in a classroom or a workshop, it's good to kind of summarize and think about the test that you just perform or the process that we studied. And I ask some questions like, does the salinity level affect the microbial population in your soil? And in the table that I provide here, I give the ranges of electrical conductivity that could affect microbial analysis and microbial population. So a student will say yes or no based on their results. If you have a salinity problem, how can you fix it? This is where they need to think about it, or look into lecture notes, or just simply Googling it and like pull up a textbook and look up some examples of what can be done. Or another one is look up some examples of salt-tolerant plants. So if you do have salinity problem, why not match plants according to the soil type? This is the point of the book or my science in general. What I teach is to match plants to the soil quality before you try to plant something.
I think that's a really good point because we talk about that a lot in class, and woody plant class in particular, where you're looking for a plant that's going to be salt tolerant. And I always say, look at your coastal plants. Look at along the coastline. What grows in those salty conditions? That's a really good place to start. And you start to think about it. And a lot of those are not propagated inland for salty roadway areas or around your property where you're putting salt on your sidewalk.
Especially with changes of regions. And I keep hearing people talk about the plant region changed, or with climate change. We briefly talked with you earlier, climate resiliency. And if we have the shifts, we need to adapt. And how do we adapt to it? By using more native plants and more tolerant plants to the environment. So I think we should start implementing this in the landscape for sure.
So you really piqued my interest just now. Can you talk a little bit more about salinity and microbial populations? Because I need to know.
Ooh. Well, if you go back to the book, let me pile up again. So I provide here different measurements. So if you measure your soil, basically you take a soil and can mix it in with water. Well, in this case, I have an example of 1-to-1 salt to water suspension. There are different ratios that you can use, but this is the easiest one. And you put a probe into your suspension, and it gives you a result. And wherever the result, you get different units. Salinity is a little interesting. It can come in different units. And it comes just historically, people use different units. Different countries have different units. But the good thing is, you can all convert them one to another. Simple, you can Google salinity calculator or converter, and it will do the job for you if you don't want to do the math. But then it tells you, let's say, very often we get a total dissolved salt is commonly used, it's part per million or milligram per liter.
Right.
Well, it's 0 to 630 is non-saline class. Plant's response is negligible. Microbial response, few organisms may be affected. But then if your salinity goes up, you get high electroconductivity and you have higher total dissolved solids. And then you can go to very highly saline, to sensitive plants may be affected. There may be some nitrification and denitrification processes that are altered. You go to even higher, slightly saline soil, you will get most plants are affected, and microbial response for respiration and ammonification processes can be altered or influenced. If you go to moderately saline soil, only tolerant plants survive. Salt-tolerant microorganisms predominate, actinomycetes, some bacteria, and fungi. And if it's a soil that is very strongly saline, only very tolerant plants survive. Very salt-loving organisms are active. So basically,
salt-loving organisms. Okay.
Yes. So you can get the range and see of what your number falls into. And
the sea kale is highly salt-tolerant. Sea kale, they used to put covers over it so that it would be bleached, so that it would be really tender, and it would be white. But it was very salt tolerant. So looking for that, when we do studies along the beach, we look at the different fungus, and there's one in particular, I think it's called Telephora fungus, and it's brown, and it looks like a cow patty when it turns into its fruiting body, but it's one of the very few that can grow right up along the dunes on the first dune level off the beach. And it is there to actually help to stabilize the sand, but also can take the salt. And it helps to stabilize the dune grasses. And so fascinating to me. Now, what made me think, he was talking about salt, is what happened just now in Florida, where you might not typically have a storm surge that might be salty going so far inland, that a lot of the inland plants are going to be affected, and they're not going to see it right away. They're going to see it later after the fact. And that was something they were talking about on the radio this morning, about how far inland did the storm go, and bringing that salt water is going to really affect the plants inland. And
unless they get some good rain, that will.
Yes. And you're absolutely right about that, because that's going to just flush out the sand in the soil, right? Because their soil is much more sandy than ours is.
Yes.
But I think that's really fascinating. I think it's just a wonderful book. Really, it's a very universal book.
Well, I want to reiterate, too, that the book is clearly an intro to soil science. and then moves quickly, like we've been talking about, into a series of tests. As I went through it this morning I thought, oh man, I've been wanting to refresh my brain because it's been a long, long time since I sat in a classroom and learned about soils. I did a fair amount in terms of the applied science in the field for trees, but it was just so great. And it made me realize that as an arborist, I've always had kind of a soil-based orientation. I went to those conferences, the Landscape Underground. I hope they reach out to you and that you're in the next program, because I know it's happened to you because you're a soil person. You sit there and you kind of light up thinking, man, if we all better understood soils, we would really have a plant community that was vital and happy.
It's true. And I'm always surprised, especially like in some landscape design industry or landscape text, like they don't study much soil, which is surprising me. By definition, landscape is soil, and everything starts with soil and everything ends with soil. So I think you can make much more informative decision and like really cut on your costs by understanding more what's in the soil, so you can match plants according to the soil quality. And if you need to amend it, to change it to the plant you want to grow, you will know how to do it in a more mindful way.
It got me thinking about hydroponics and why hydroponics came about, because of maybe something that it could have come about because of something that was affecting the plants. But the idea of having floating islands in lakes to grow your vegetables was a really big thing in ancient times. And I think to myself, okay, well, in hydroponics, you have much more control over what you're putting into the mix. Whereas in the soil, you really have to understand the functionality of everything in the soil, including the microbes. And when I say microbes, that includes all the little nematodes and the fungi and the bacteria. And there's so much more in the soil than there is if you're doing hydroponics.
Yes. Yeah.
I have to ask, if you'll indulge me, what is your take on compost tea? Because it seems the controversy just won't go away.
What is the controversy you recently heard?
I went to some workshops several years ago on making compost tea. It was a well-done 3-day workshop put together by a tree care company north of New York City. And at the time, the way it was being presented is compost tea will cover all bases in terms of aspects of tree care, including applications, foliar applications as a fungicide for difficult funguses, along with the applications at ground level as I don't want to say fertilizer, but improving soil biology through regular compost tea applications. And I just love the idea. But then a deeper dive into it is like, maybe a little too good to be true. I guess that's where I'm seeing the tension, the two camps.
I wonder why they think it's too good to be true. It's not enough nutrients, or it's not strong enough.
I think it was more the science of the product that you're putting on the ground, that you're brewing yourself. Are you really delivering living organisms, or is it just brown water?
Okay, that's a good point. This is what I was thought in my head, that I think it's all about recipe and testing, right? So it's good to get the soil conditioner, and I've seen like people do it, but I think you want to know what you're adding, so you're actually making an impact, and this is why testing is really important. And there are some simple probes as well these days that you can use to analyze the presence of microorganisms or bacteria fungi ratios. So this is something that people can use to see if compost tea is effective. But overall, recipes are really important in amendments, not just the liquid, but the solid specifically. And I'll come back to my favorite metal topic. When we did in Louisiana, I had the lab, and we tested not only soils, but also amendments. And we found a lot of things that shouldn't be there, including heavy metals, because the product that was originally used had like maybe natural levels of contaminants comes from rocks. But when you create the concentrated material, its concentration increase. And then you're not only adding new good stuff, but also some metals along with that.
Oh my.
So it's really important to know, even if you use product yourself, if you create it yourself, what is the source of the materials? You're not going to harm the environment if you add just brown water. It may not like you have a really beautiful yield that you expect, but at least you're not harming it. But if you keep adding cadmium into your soil by not knowing what's in that rock fertilizer that you add, it becomes an issue. Really, we need to be mindful of the sources of our materials, what we use ourselves or we buy from vendors, and do testing. It's good to maybe choose a vendor and test them a few products, see what they get, and you stick with them.
But you're saying over-the-counter amendments, some of your research indicated that they could potentially be a source of metals.
So we were testing amendments that some companies sent to us before they would go to commercialize them, or they were maybe selling them, and we tested some of the products that found very high concentrations of metals in them. And this is why recipe is really important. And and I hope they changed, their sources because I'm sure to make it commercially available and get certificates on their product, they would need to go through the lab certifications. But different states might have different regulations. So I don't know how it worked overall. But we need to be mindful of what's sold. And we did testing actually from stores, some compost back several years ago in New York City, and we did find some elevated levels of lead in compost.
Oh my goodness.
Yeah, so it's really, and we couldn't get information from a company where they took this source from. So
pretty unregulated, I'm assuming then. The bags that you're getting at the big box store, probably
it's
an
very
unregulated.
hard sometimes to, you get sources like even a plant material compost, you cannot really test every single pile.
Mm-hmm.
And something in the way got polluted, or if the pile gets open, it just sits there for months outside.
Oh, sure.
And so it's really, really hard to monitor every single pile that comes out. So that's why really important, again, do testing, a little investment, and then see if you trust the company, stay with them. But yeah.
I like the idea of using the leaves from your from your trees and grinding them up and putting them back into your beds, unless you really have high contaminants. I mean, that's really the best soil soup, compost tea, because you're using the leaves that are there, and it's making compost as it rains. I mean, it's making that tea as it rains. And we see that even in our streams in the fall. When the leaves fall into it, you'll notice that the clear stream starts to turn black or dark color. And that's a really important thing for fish, because I know that some of the bivalves actually need leaves to regenerate. The leaves collect along the bottoms of the streams and the rivers, and it's used for bivalves for laying their eggs. And I just find that to be really fascinating, because leaves have so much nutrients in them and provides additional nutrients for the soil.
Yeah, and if you can use your own compost, you can make your own, it's great, because you can control what adds into your pile.
Yeah. Tell us a little bit about how you wound up in Louisiana and then now at Purdue.
Yeah, that's a great question. I did my PhD in New York City, as I mentioned, right before COVID. Yeah, I graduated in 2019. So in 2020, I was applying for jobs. And at one of the conference, my colleague gave me a piece of paper and said, oh, look, they advertise a position at the University of Louisiana at Lafayette. You should apply. And I did, and in January. And then in March, a couple of days before COVID shut down, I went to Louisiana for the interview. And I came back the night before shutdown in Brooklyn. So, yeah, I just made it. And then a month later, they made me an offer to come to Louisiana. So I did. And I was lucky, I guess. Many people lost their jobs during the time. And some of my colleagues lost their contracts because of, uncertainty. Sure. But I got really good opportunity to go down to Lafayette. And I had a good time eventually opening my lab after we could come to campus, because the first year we were really limited on in-person interaction with students. Everything was online. It was very challenging, but we managed it. We had a good time online as much as it can be. But I was able to open up a lab, Delta Urban Soils Lab, where we tested soil and amendments from Louisiana and beyond, from many other states. People sent us. We have done research on contamination, some innovative remediation, including some of my students did the capstone projects on using even shrimp and seasoned and non-seasoned shrimp and crawfish as the food waste in Louisiana for growing vegetables or vermiculture compost. Another student did was some good stuff. We were able to map Lafayette for heavy metals, and we found that there are some hot spots, again, in historical sites in inner city, elevated lead compared to other areas. And then earlier this year, well, just a few months ago, I moved to Indiana. They made me an offer I could not resist, and I moved to Indianapolis. You can see my view. It's a really interesting city, industrial past. I'm excited to learn more about this contamination problem. I know there's some professors already done work on the lead in Indianapolis, so I'm excited to potentially work with them and build a new lab and new team on the Purdue campus. But I will be still specializing on urban soils. I'm the first soil scientist who specialized specifically on urban soils. And I have a dual position between two departments, agronomy and horticulture and landscape architecture. So I'm in between two departments, which is also exciting to kind of step in both roles. This year, I'm not teaching anything. I'm establishing my program, meeting lots of people, learning who is doing what, and starting collaborating with people. And the next year, I will start teaching a course.
That's wonderful. And one of the questions I have for you is, and I thought it was a really interesting story. So, because we had talked before this podcast, can you tell us a little bit about how you got the name of your company for your soil company? I just love it. I love the name of it.
Well, House of Soil, it was actually created by a friend of mine who is a brand stylist. And I'm not only passionate about the soil, but also interested in fashion and elegant side of it. It's the style and how we present ourselves. I think it's really important when we interact with people and how we stand out in the crowd, especially room full of PhDs, like what is that little detail that can make a difference? So I share a lot of tips with my students on etiquette and how to position yourself, how to have your voice. But a lot of it is also how we dress and what we do with our clothes. And when I first visited Mexico City during conference 2015, I had a aha moment when they took us to a creek full of eroded garbage and mixed with soil. It was lots of like clothes. And I was like, oh my God, we don't see it in cities because someone, even if we donated, I don't know how much it actually goes to other people. Some of them, most of our clothes end up somewhere else in the environment, and fashion becomes a really big problem. It's a huge pollution source. And I was like, I have this knowledge of soil. Everything comes from even fiber. Our clothes originally started from the soil one way or another, and it ends up there. I think we need to combine these two industries. And what I see is that sustainable fashion and regenerative fashion nowadays become more buzzwords, but I would like to see more science and more scientists in the sphere, because I think we have answers that can help fashion experts to make more informed decisions and help new emerging designers who want to create decomposable clotheslines. And this is where we can collaborate and also make it more attractive to young generation of students who want to shake the world, make real impact and difference, and we can start it with ourselves. So House of Soil is about advancing fashion industry and regenerative fashion through the knowledge of soil science.
Love it. I just love the name of that.
I just had an aha moment. That's amazing.
Thank you so much.
Growing up in a tailor's home, my mother was a tailor, and we were always involved with sewing. I mean, I got my first scholarship through sewing. And you think about what clothing is made out of, and it doesn't disintegrate, doesn't break down. And they're some of the biggest pollutants that we don't really think about.
And all the dyes and plastic, it gets to the soil, to the environment, to water, and we don't see it because we, live in luxury. Someone else takes care of it, and we're in the city. We can just go and buy things and throw them away or donate. But who takes care of them? Now, of course, a lot more companies who are doing some recycling or upcycling, but we're still way ahead to make a real impact and difference. And it's all about also making more consumer decisions, like do you really need a shirt? Or can you buy a piece of clothes that is a quality? It doesn't have to be expensive, but something quality and timeless that you can wear for longer time, for years. And you have a, I don't know, personal style. You wear it with a different jacket, different shoes. People think that I love shopping and I'm like a shopaholic because I always dress up. But in reality, I have many of my dresses for multiple years. Some of my dresses actually from my sister and who wore them for years. And I just love the style of the colors. They're timeless and always like fit in because they're classy. And we do sister swap with clothes. This is my way of being sustainable, or more or less sustainable, is to choose something that can simply last longer and you can combine it with other items. And this is how I get by, because I actually don't like shopping and figuring out what to buy and go through the whole process of it.
And, this is all kind of triggering some ideas in my head that what if you ground up fabrics and made them into some kind of concrete, or something that could be made into a house, or something that could be made into a bench, or
insulation. Make it into insulation.
Insulation, yeah. Something like that would be really cool. And again, we're taking fibers from plants, we're taking fibers from trees. People really don't realize how much is coming from the plant world when we are making fabrics.
Exactly. This is why I want to come in and share this knowledge and inspire other people, inspire perhaps younger generation to come up with ideas like brick with fabric or, insulation things, because they're so creative these days. And now like with technologies, I think we can make real impact. But what is missing, I think, is a knowledge of soil that could be really a driver to make the change.
Well, at the very least, we should be buying clothes that ultimately we can compost.
That would be nice.
Yes. Yeah, I know burlap breaks down within
as long as it doesn't have a plastic cover in it, or as long as it doesn't have copper on it, those are the kind of things that were invented to stop it from breaking down. And that,
right. No, good old school brown burlap is what I was thinking about.
Exactly. Yeah. Well, we have to ask our question. Do you want to ask it, Hal?
Yeah, because I want to embellish on it. So you grew up in Russia. Tell us the region of Russia that you grew up in. And also, are there trees that you saw there maybe that you now are seeing in North America? Is there a species
I
there?
love that question.
Yeah. That's a good question. So I'm originally from Stavropol. It's this state in the south of Russia, relatively close to Sochi Olympics 2014. I grew up in a couple hours away from mountains, Caucasus Mountains, a very special place because it's famous for mineral waters. People go there to resorts of like medical spas to take a bath and drink mineral waters under supervision of doctors. And it's an area with endemic species, endemic plants and like trees and plants that only grow in that region. So it's really unique place. And I think my favorite group of plants, I was thinking about it the other day. First, I wanted to say maybe it's apples, like just apples, because I grew up having vegetable garden. Like we had the peach trees and cherry trees. And I was like, I have this apple tree in front of the window and I love the smell of it. But then I was like, you know what? Every time I pass by pine trees and I smell them, I was like, no, it's the pine trees. And so, yeah. And in the Caucasus Mountains, that region, like we go for a walk, they have a special, they call them Terenkur, is the paths across the mountains. So people go there just for a walk, for hike, but it actually has lots of benefits to the organism, to your organism, because of the pine trees. And they release compounds that help healing organisms and killing microbes, like negative like pathogens in our body. It's really good for respiratory disease and cardiovascular disease, because people walk and breathe through this really amazing trees, but also hiking up. So it really has like healing powers. So I think my favorite is the pine trees.
That's a lovely answer. And just hearing you talk now, it makes me realize, even though you're a scientist, I think you still love and respect the healing powers of the old traditions as well.
Of course. Yeah. And the working with soil, with land, it makes us, plants, gardening, it just makes us happy, and it is scientific proven.
Well, it's been delightful to have you on our podcast. And I know that people are going to really dive into your book because it's a good way to learn about soil and not feel overwhelmed.
Good.
That's well said. Yeah.
Yeah. And we hope to have you on again. We wish you the very best at Purdue. I can't wait to hear what you're going to be doing down the line.
Thank you so much. I really appreciate joining you today and maybe connecting with your audience. Feel free to reach out to me, and you probably have my contact information on the webpage. So feel free to reach out and DM me on LinkedIn or Instagram. I will be very happy to chat and learn more.
Excellent. Thank you so much, Anna.
Take care.
Great.
Bye-bye.
My pleasure.
Bye-bye.
The Plant a Trillion Trees podcast is edited by Andromeda and Recordings in Hollywood, California. Thank you.